if you want to install Crystal, these are a few short commands, and there's more in-depth and more operating systems available at that URL. So what I'm going to talk about today is why every Rubyist should consider learning the Crystal programming language. This is going to be very surface level. We're not going to go into depth. My intention is to pique your interest, and you can certainly ask questions afterwards. And it's easy to play around with if you're coming from a Ruby background, and we'll see some of that. So why? Why even bother to learn Crystal? I contend that it is at least as easy as Ruby, meaning that it can even be easier after you get over the learning curve. So the syntax is strikingly similar, and then you get some additional features, some core advantages that we're going to talk about, and then I'm going to go into some of the additional features of the language. And then one framework in particular, the Amber framework, but there is a huge ecosystem of libraries and frameworks for Crystal already, and it's ever growing and evolving. So with that said, easy as Ruby. I'll show you a couple of code examples to highlight this, both for this and some of the core advantages. So the first one here, it's kind of hard to see. So this is a module to compute the Hamming distance between two DNA strands. That's not that important. What's important is if you look at some of the code that's used here, you'll see a lot of Ruby features. We're raising an exception. We're using a post condition with an if statement. We're using chars. We're using zip. We're using count with a block. Using put statements, right? So all of these features of the Ruby language, from enumerables, post conditions, that make it syntactically friendly, right? So I will just run this. And we just see the output, and you'll see it just gives you some numbers there that tell you what the Hamming distance is of those. So I'm going to show you how to port this to Crystal right now. I'm going to use this as a starting point, and I'm going to copy it to a CR file, which is Crystal's extension. So now we have this here. How many line changes does anybody think I'll have to make to get this to work in Crystal? Any guesses? 4? 2. 2. Do I have anybody else? 3? 0. That's the Price is Right strategy, right? Let's see if Adam is right. 0 line changes. That's how similar Crystal is to Ruby. And then, so you get this syntax plus some other things. Is anybody here familiar with using a static and or compiled language? Okay. If you've ever been wanting for some of the advantages that those give you in Ruby, you can picture Crystal as being Ruby plus those advantages. And we'll talk about a few of those now. So speed is one big advantage. And I could show you with the Hamming distance calculation, but I'm going to show you another one using reduce that's going to really highlight the speed differences that you can get. So we have this benchmark here, and you'll see again the code is strikingly similar. One small difference here, if you're hard coding a number in Crystal, like the number 1 can be represented with a regular integer, but I want this to be what we call an unsigned 64-bit integer. And since it is so small, I just give this designation. But other than that requirement, it's the same code as Ruby, right? So let's look at benchmarking these two. So for Ruby, I will just run directly the file. For Crystal, I pre-compiled. So it shows the answers here before it runs the tests, and then 100 times it will do these reduce calculations. So for Ruby, the first one takes almost 8 seconds. The second one's going to take around the same time. The third one is a little faster. And then the next benchmark is called iterations per second. It calculates how many of these things Ruby can do per second. So for the first one, 1 million numbers inside of a range, 14 per second, almost 15 per second for it inside of, range and then array. And then the random numbers, it can do about 1.3 thousand. So now I have a compiled Crystal app, and you saw the code is almost the same. And we're going to see how fast that runs. So everybody keep your eyes open, don't blink. That's how fast it ran what it took Ruby 10 seconds to do. Now we'll look at the iterations per second. For the first two, it's not really a fair fight because the compiler has an optimizer, and essentially, come on. Essentially, it can probably look through the code and figure out how to pre-calculate that. But the last one is random numbers. So that is a fair fight between Ruby and Crystal because at runtime, those numbers are going to be different. And does anybody see this number? It's almost 500 million per second compared to about 1,000 for Ruby, right? If you do the math on that, that's about a 500,000-fold speed increase, right? This is a cherry-picked example, of course, but you're always going to get at least a 10-fold, in my experience, performance increase just by switching to Crystal, right? So 10 times better is your baseline. 500,000 times better is the upper echelon of that. Cool. Any questions so far?
There is there's a huge.
Theoretically, if you're running C code directly with minimal overhead, it should be very close. It should be very close. I think the difference here is going to be, for Crystal, it is 100% of the language is going to be compiled and fast. Versus with Ruby, you're either, like you said, you're going to have to dig in to the C code and extend it yourself, or know what's good and what's slow.
But my question is that because unlike has decided.
It's so Crystal, most of it is implemented high level with Crystal. It uses something called LLVM to get it to low level. And we can talk, that deserves its own discussion. We can talk about it afterwards. But that's where the real magic happens is Crystal goes to LLVM bytecode and that gets compiled and that's fast. Yes? It depends on the code base. And it also depends if you run it with compiler optimizations, the compilation step takes significantly longer than if you run it without the optimizations. So in development, it only takes maybe 3 seconds for certain applications, and then when you run it with release, it'll take 10 to 15 seconds. You're not talking about 30-minute builds, but sometimes it will interrupt your flow compared to a fully dynamic language, for sure. Cool? Okay, method overloading. How many people here know what that means? Cool. So method overloading is supported straight out of the box in Crystal. And we're going to look at one example. And even if you don't know what method overloading is, you'll have a decent idea after this example. So in Ruby, when these put statements are executed, does anybody have a guess what the output will be for each of them? Any guesses what this is going to say? It's going to be the last one. Ruby overwrites as it goes down. So the last method is the one that is actually used. And we can verify that. Cool. So it uses the same method at the bottom. It doesn't care about the ones that you wrote earlier. Now, you don't have any other options really unless you change the names or if you do a switch statement based on calling .class or something like that. In Crystal, if we have the same code, it will do the same thing that Ruby does. But what we can do instead is we can type the arguments, right? So that's going to be an integer, that's going to be an array, string, and hash. So now I've typed all of these. They're overloaded methods. They're different. And if we run this code, let me comment out this last one. So it runs the method that we expect based on the overload, right? And so you have more type safety with this. If you want to definitely deal with an integer, you type the input as an integer, and you know no matter what, when that method is called, you're dealing with an integer. You don't have to do any inflection or anything like that. In addition to that, you can get more detailed. So for a hash, you can have different keys and values, right? So if we have a hash that has keys that are strings and values that are strings, I can write a method here that handles that and leave this other method for all the other hashes that exist if they have different keys and values. And then same thing, when we run that, instead of the bottom being unknown type, it catches the one that's string as a key and string as a value, and then it leaves the one that's more permissive, right? So if you're not familiar with method overloading, that the value of that might not be apparent. If you are, I hope the value of this ease of adopting method overloading is apparent. And additionally, you can leave a catch-all at the bottom. So this would be a tuple, which don't worry about what that is. It's kind of like an array. And then if we run it again, the bottom one says, I don't know what this is, because essentially we didn't type that. Now, the last piece here is compile time checks. And I'm going to show you a quick example of that. If this didn't exist, this method here, and all we have is these typed methods, this is going to send a tuple, which we haven't coded anything to deal with. We don't know how to deal with a tuple. But the nice thing is that will be caught at compile time. So if I try to run this, it's going to give us this nice, hey, there is no overload that matches sending a tuple that contains a string and a bool. Here are the overloads that are available, int, array, etc. Right? Now, catching this at compile time means that it's pretty much impossible for you to deploy code with this error. Your build step would fail immediately, and it catches that error. You don't have to wait for runtime in some weird state in production. This is what people mean when they say type safety. The compiler runs first and makes sure that you've lined up all your types before you try to execute the code. Okay? And when you get larger and larger systems and larger code bases, the value of that goes up. Cool. So those are the core advantages. These are additional features. I might show one of them, but otherwise I'm just going to talk about each one a little bit. Spec is built into the language, so that's not a separate, what they call shards is what Ruby calls gems, so you don't have to choose between mini-test and RSpec and whatever else is out there. Spec is built into the language. HTTP server and client, both built into the standard library, those are lightning fast. Lightning fast. They're competing with the fastest of web languages out there. Faster than Go, faster than ulib in some scenarios, which is a C library. There's a code formatter and linter. There's no more bike shed arguments about how to format code. They've made decisions. It's built into the language to format the code. You don't have to create a style guide and make sure everybody understands it. You just run it through there. You learn what the conventions are. Documentation generator. I might show you that one because I think that is a very well put together tool. And then there's an application library repo initializer. If you've ever started a project from scratch and you weren't sure how to organize it, what folders do I need? Do I need a YAML file? If I want to set up Docker, how do I do that? Crystal has something built in, and you choose if you're building an app or a library, and it sets up that structure, it sets up the configuration files, and I believe it even sets up a Docker file for you, initializes the Git repo. they've made some like small opinionated decisions that help each library's code base be consistent, if that makes sense. So those are some nice features, additional features of the language. I'll show you the documenting one because I think it's really nice. So if I go to the root of this directory and I just run crystal docs, it will go through the source directory and it will essentially create documentation for me. You'll see the HTML files. I'll go ahead and open the index one so you can see what it looks like. So this is what's generated automatically. Once you have a whole bunch of things in here, this is like an autocomplete search that's provided for you. You get this for free. So it will tell you things like the methods that are available in some detail just by writing code. You don't have to do anything else. If you choose to put inline code comments, you can get something a little bit nicer, like some information here. I can click down. It'll give you an example how to use it. That's read from inline code comments that I put in one of the files, right? And then it also knows if you've included like another module, it creates a link so you can look at documentation for that.
Can you show us those comments?
Sure thing. So it reads whatever's immediately above the module. It uses that as the summary. It uses whatever's above the definition. It will use this as the description, and then it'll take the code example and put it in the detail of each method.
If you offset it with the markup.
If you offset it with, if you offset it with the backticks. Yeah. Cool. Any questions on that?
Is that exportable in any way? I mean, obviously you get HTML.
You get HTML, so it's still, Crystal is still not to 1.0. So they're still working on some things. You would have to build yourself if you wanted the Crystal docs to automatically shoot off to a CDN or something like that. You'd have to set that up yourself. It just does it locally for you as of right now.
It doesn't do like a Swagger auto with a server and a port, your stuff automatic.
Not at this point. No. It's a manual kickoff. Yeah.
Does it throw an error? Or what's the error that
if your documentation's not formatted correctly? I don't know. I mean, it would probably just insert the content as is unless it really screwed up. So I think at worst, the markup would be either invalid or weird. I haven't seen an error yet. I think it just takes the text and does what it can with it, essentially. Any other questions at this point? You'd think that I planted you.
I'm like sold.
There is one. It's called the Amber framework. There are actually many. Full disclosure, I've been working on the Amber framework, so I'm listed as one of the core contributors. That's why I'm choosing to show that one. There's one called Kamal. That's a lot like Sinatra, if you like that. And there's another experimental one called Lucky that's trying to do its own thing. So Amber, I'm going to show you, if you're familiar with Rails, generating and scaffolding a new app with Amber will be very familiar. So we're going to do both of those things if I have time right now. How's it look, Chris? Good? Okay, so first I'm going to show you how to get started with Amber. This is assuming you have it installed. So we'll say Amber new, and everybody always does a blog thing. I'm going to do a pet tracker. Cool. So that generates a new app for you. I'm going to CD into that, and then I'm going to scaffold a pet. Amber G, short for generate. And it's going to have a name, a breed, and an age, which is going to be an integer. That's going to generate the models, views, controllers, migrations. So then I will do Amber DB create migrate. Oh, sorry, I need to drop it first. Cool, so that's there. Now this is the part that's going to take a second. This is the equivalent of like a bundle install, and it's going to have to download things. So while that's going on, we're going to build the same application in Rails.
What's it used for its default?
Postgres is the default database. It supports MySQL and SQLite as of right now. There is an ORM. We'll look at that in just a minute. Okay, Rails new. Rails pet tracker. Oh noes. Makes everything faster. Okay, so that's going to happen. These gems should all be cached, so that should be quick. We'll get into there. We'll do Rails, G, scaffold, pets, name, breed, age. Oh, don't hang up on me, come on. Okay, good. And then we'll do Rails, DB, drop in case it's already there. Create, migrate. All right, so then we'll bring up the Rails server. I'm going to put it on port 4000 so we can also run Amber server. Cool. So if anybody's ever scaffolded something in Rails, this should look pretty familiar. Does anybody have a pet they want to track?
Charlie.
Charlie? How old's Charlie? Like 3, 2?
2 last week.
Cool. So this all looks familiar, right? A RESTful resource, all this stuff. Let's check and see. Okay, so this is done. So I can do Amber watch. That's similar to Rails server. It will watch for files that change, recompile, and start the app again. So we'll have to give it a second to compile, and then it'll bring the server up. Now we're good to go on port 3000. Pets. We'll put Charlie in here again. Hold on. 3. Submit. Cool. So, similar functionality, right? What I want to point out is different database, same exact structure. Because it'll use the name of the app. So one of the databases will be called Rails Pet Tracker _ development, the other one Amber. So the thing that I want you to notice here is this symbol, right? That's the microsecond symbol. If anybody's never seen it before, that's less than 1 millisecond. So this is essentially 3/4 of a millisecond response time. And you'll see this a lot when you use Amber. Now, if we compare that to what we have in Rails, we've got 75, 65 millisecond response times. Now, to the human eye, that's almost imperceptible, right? But to your server load, that is maybe you can handle 70 times more traffic, if that makes any sense, because you're processing the requests in less than a millisecond instead of processing them in 75. Does that make sense? Yes, sir.
How does that frame? Because I mean, I'm looking at it right now, and it's 75 milliseconds.
In the views. So the way that there's a templating language called ECR, which is I think exactly the same as embedded Ruby, as ERB. They also have something called slang, which if you've ever used slim in Ruby, it's the same thing as that. But since it's compiled, at the end of the day, it's essentially a string that's going to be about as fast as a string in C. So it's the compilation step, but when you're coding it, you're coding it exactly the same way that you would ERB or exactly the same way you would in Slim. But the speed, a lot of it does come from the view, absolutely. And we can take a look. We can take a look at the code, and I'm happy to stay afterwards to dig through the code. It follows model view controller, so you have the same structure. There's a routes file with pipelines and routes. You can do resourceful routing. All that's there. The ORM that this uses is called Granite. It's very similar to Active Record. It doesn't have all the functionality yet. There's another one called Crecto, which is like Ecto in Elixir, if you've ever used that. But yes, a lot of the speed comes from compilation rather than dynamic string building. Absolutely. Any other questions about that? Okay. Just a couple more things, and then I'll be out of your hair. So what's behind the magic? As I mentioned, LLVM. That you could write a PhD dissertation on LLVM, probably many times over. So I can't do justice to exactly what it does. But the high level, what Ruby's done to make programming easier for humans to understand, LLVM is like a translator that makes it easier for computers to understand the code that you want to run. So in the past, there's been kind of this trade-off between having a dynamic high-level language and having a low-level language that a machine understands. And LLVM helps bridge that gap. And Crystal basically bridges the gap towards human readability and understandability. And then it passes things off to LLVM to make it understandable for the machines to execute quickly. That's the layman's understanding of it. There's a consulting company called Manas in Brazil. They are behind this Crystal language. It started as a project maybe a year and a half or two ago, and they have donated lots and lots and lots of developer time. In addition to that, there are over 250 contributors to the language thus far. That doesn't include all the libraries and frameworks. If you include those, there's easily thousands, probably tens of thousands. But to the language itself, over 250 contributors. Yes?
Why? Was there motivation?
I think that they wanted the ease of Ruby and the speed of C. They knew how to use both, and they knew they could be more productive. Actually, there's bullet points. So this is Crystal's website. That's how easy it is to do an HTTP server. Yeah, so here was their goals. So I think that's what it was. They wanted productivity without sacrificing speed. And I think it was just a pet project by somebody on their team named Ari, and it took off to a certain extent. Okay, if you're sold on any of this, these are the easy ways that you can help. GitHub stars help essentially get traction and get attention. So if you want to star Amber or Crystal, I would appreciate that. Try them both out. Submit issues, submit pull requests as you're playing around with them if you like. And if you feel super stoked about it, Crystal, like I said, the team at Manas is essentially subsidizing this with hundreds of thousands of dollars worth of programmer hours. And you can financially support it by this thing called Bounty Sorts, which is kind of like Kickstarter for open source projects. Cool? So that's it. Thank you. I'm happy to take any questions now or afterwards. Chris.